And it's a great pleasure now to introduce Professor Lawrence Principe. Known as Larry, he is the Drew Professor of the Humanities at Johns Hopkins University in the Department of History of Science and Technology and the Department of Chemistry. He has PhDs from Indiana in Organic Chemistry and Johns Hopkins in History of Science. His principal research focuses on the late medieval and early modern periods, with special attention to the history of alchemy and chemistry. Working on Robert Boyle at the moment. It's absolutely fascinating stuff. He's also very active in the science and religion area from the historical perspective, teaches classes on that. He's produced a 12-series DVD on that topic of science and religion. And he's currently planning a major museum exhibition using alchemical art and artifacts to display and explore the close interdependence of science and religion in the 17th century. He's especially interested in how theological interests drove scientific exploration and innovation, and how such interests were manifested in scientific systems. So, the role of religion in the emergence of modern science. Thank you, Larry.
Thank you very much. Well, it's a great pleasure to be here to address you all. I will give two lectures today. They're going to interrelate to one another, so there may be some points I bring up in the first one that may not be answered entirely, but please ask about them if you're interested in them, but I may be saying more about them in the second one, because the two topics do correspond a bit. I was very pleased to be here to hear Professor Chapman's talk yesterday afternoon. It gives a very good introduction to, or entree to the things I'm going to talk about, because our two perspectives, his on the Middle Ages and mine on the early modern period, that is from about 1450 to about 1700, 1750, coalesce in a number of ways. Perhaps one of the most important ways, something that he commented on repeatedly, was the inseparability of theology and science in the Middle Ages, and that continues through the early modern period. We're going to see many examples of that as well. So, without further ado, let me begin by looking at some of the religious background or religious motivations, theological motivations, to the pursuit of science in the early modern period. So, I guess we can start with some questions. Were there in fact theological and religious motivations and backgrounds to the pursuit of science in the early modern period? If so, what might they have been? How might we identify them? How can we tease them out from the subject of early modern science, identifying theological and religious either contexts or motivations? Well, there are a lot of different methods that we could use to answer this problem. But I'm going to sidetrack us first before we get to those methods. And instead, we should stop for just a minute, I think, to ask why we are asking the question in the first place. Because the question, we talk about the religious foundations, let's say, to science, that question, were there any, might strike a lot of hearers, probably none of the hearers in this room, but many hearers as odd or unusual. Yet, think about it for a moment. Would we be surprised to be asked a question about the philosophical background to modern science, or the methodological background, or the sociological, the political, the economic backgrounds to science? I think not. I think that there is quite widespread this assumption that science and religion are to keep a reasonable distance from one another, and the idea that religious ideas, religious ideals, and even theological dogmas of a very specific sort influenced the development of modern science strikes some hearers as being a kind of a heresy. Not a heresy against religion, but a heresy against the religion of scientism, let's say. Now, where does this idea come from? Let me see. I'm terrible with technological things, so bear with me. And this one has only 4 buttons. You should see me with things that have more. There. The fault for the notion that religion has no or purely negative influences upon science lies on many shoulders. But as many of you will already know, the blame lays probably on these four shoulders more than on any other shoulders or pair of shoulders. People I'm showing you here are John William Draper and Andrew Dixon White, both authors of extravagantly popular texts of the late 19th century. They wrote the kinds of books that any professor would be very happy to write. Bestsellers, still both of them available in print and on the internet over 140 years later. Draper, let me give you some background on them. Well, let me tell you what they wrote first. Draper wrote a book called The Conflict of Religion with Science. White, in 1876, gave a lecture in Philadelphia on the warfare of science and religion, which he worked on for the next 20 years, publishing in 1896 a great 2-volume compendium of all the problems that religion has caused for science, called The Warfare of Science with Christendom. Now, who were these people? John William Draper was the son of a Methodist minister who had emigrated to the United States from England. He was a chemist by profession. He was particularly interested in photochemistry. He is credited with taking the first celestial photograph, a photograph of the moon. He is also one of the founders of the American Chemical Society. So, no slouch in this sense. Andrew Dixon White was a historian by training, the first president of Cornell University in New York State, in the US. He also became president of the American Historical Association, held that post for a number of years. Well, what's the problem with what they wrote? The problem with what they wrote is that it's almost entirely wrong. There are two problems with it. One, there's the fact that historically, the basis of what they wrote was, well, there was no basis. It is to these people, in particular, I'll give you just one example, Draper, who wrote first, 1874, 1876, to which we owe the terrible myth to which innocent school children all over the world are subjected, that people before Columbus thought the world was flat. Now, if you want to know where he got this from, you can go to his book and you can find the footnote which says, Irving, Life of Columbus, which is a reference to a romantic story about Christopher Columbus written by the poet Washington Irving. And it has been propagated from generation to generation to generation. Draper's book on the conflict of science and religion was published in a series of popular histories, popular science. It was an attempt in the Victorian period to popularize the burgeoning sciences to the masses. His book outsold all the others by an order of magnitude. We still find it quoted, often by the self-proclaimed prophets of scientism, as being an authoritative source. But historians know that both of their works are extraordinarily deeply flawed. In fact, if any intelligent person who knows a little bit of history reading Draper, it's hard not to giggle when you read it, because it's just so absurd. High-flown prose, and just crazy claims about the Middle Ages, about the early modern period, and so forth. Now, as I said, these were no slouches, these two people. They were intelligent people. Why did they write anything so bad? Well, we have to look at the context. Both of them were writing for extremely personal reasons. On the one hand, Draper's book is a diatribe almost entirely against Roman Catholicism. The reason for it was that he was extremely worried about the influx of Catholics to the United States, particularly by Irish immigration, and he wrote a number of tracts against immigration. It's partly anti-immigrant sentiment. He went completely crazy by the First Vatican Council, the philosophical statements, and he writes this tirade against how horrible the First Vatican Council's calendar of errors is, and then he publishes it, and you read through and you think, well, that's fairly mild, all of that. Is there something behind it? Well, yes, in fact, there's something extremely personal about this. That shortly before he wrote the book, his sister converted to Catholicism. So there's an extremely powerful personal bias that runs throughout his text. White, on the other hand, as I told you, was the first president of Cornell University. Cornell University was founded as a secular institution, and he got quite a bit of criticism of founding and running this university without some kind of affiliation with an established Christian denomination. And so his writing is in the form of a self-defense, saying essentially Cornell University does not need to have a link to an established Christian denomination, and here's why. Whenever a Christian denomination has gotten involved with education or science, it's been a bad thing. And so he writes 2 volumes, almost 800 pages on this topic. Okay. So I think these are very biased, but unfortunately I wanted to talk about them at the beginning here just simply because it undergirds the response that most people will have to our question about the religious foundations to modern science. And you need to know these are the folks to blame, essentially. All right. Now, having examined a part of the basis of our question, now let's go on and look at how to answer it. And it can be answered in several ways. One of the ways of looking at the question is to say, did religious people lay the foundations for modern science? Well, that's an easy question. Of course, absolutely. If we locate the formation of modern science in the early modern period, roughly 1550, 1500, 1750, obviously, all of the natural philosophers, who we call scientists today, were practicing and believing religious people. People who were not, that is, atheists or agnostics, were essentially unknown in the period. There were a few notorious examples, but you can list them on the fingers of one hand, maybe 2. Very, very few. Although, as I will show you in the next lecture, there was, at the end of the 17th century, a particular lurking fear, particularly in Britain, about the growth of atheism out in the world, silently growing. We'll talk about that next lecture, though. Still, I don't find this kind of an answer, that yes, religious people did science, to be either interesting or satisfying in the least. It does refute the foolish and groundless notion that one cannot be both a person of faith and a reasonable, productive, scientific thinker. But it doesn't make a positive connection between religion and science in any kind of meaningful way. It's sort of like saying, well, let's see, most of the people who did early modern science were right-handed, therefore right-handedness is necessary or an important prerequisite for doing science. Right? Okay. So we'll move on beyond that one. We might ask next another way of answering the question. Did religious institutions and religious culture somehow support the development of science? This approach gets a little bit more to the point, and I don't have to talk about this very much. You heard Professor Chapman's lecture yesterday about the foundations of the universities and so forth. So I'll just repeat what he said, that in early modern Europe, the Christian church, particularly the Roman Catholic Church, was probably, I think without question, the largest single patron of learning and scholarship, not to mention the arts. And this patronage can come around in a lot of ways. It can come from a direct sort of patronage where religious institutions actually pay the salaries of particular people or pay consultant-type fees for natural philosophy and for technology. For example, in early modern Rome, there were any number of large engineering projects. And The Vatican works like any other kind of administration or a big business enterprise, that they ask consultants for things, and they put out things for bid. So things like moving the obelisks of Rome, great engineering projects. These are put out, they're paid for by the papacy, and a lot of technological and scientific work is done in this way. I can mention three other people. Pope Leo X, one of the Medici popes, early 16th century, created a court around himself of humanists, in which Copernicus was very warmly welcomed. Not Copernicus himself, but Copernican ideas. Pope Leo X did in fact invite Copernicus to Rome to help work on calendrical reform, but Copernicus answered that the length of the solar year was not well enough known yet. Another one, Gregory XIII, who founds commissions to actually solve the calendrical crisis of the end of the 16th century. And another one that I think we need to know a lot more about, historians have not studied him a great deal, Benedict XIV, an early 18th century pope who put money towards the founding of scientific institutions in his native town, of course, of Bologna, including, very interestingly, and I don't know that there are any studies of this yet, a scientific society particularly for women, where all the members would be women. This is extremely interesting, but I'm afraid I don't know anything more about it at the moment. Other examples are what the historian of science John Heilbrunn has told us about the use of cathedrals, particularly in Italy, as solar observatories. More broadly, we have the issues of the universities, and one thing that we didn't hear about yesterday was what the university founds itself on, and that is a culture of disputation. What would a university be without people having arguments with each other? Well, the University of the Middle Ages is founded on it's not so much on lectures, it's on disputation. And the way students learn is by doing disputations. This kind of culture of disputation, it becomes the normal culture of university learning by the early modern period, and it is in that culture that scientific debate as well, initially largely theological debate, but then that kind of model can be transferred just to scientific debate very easily. Fourth, another way of patronage is by providing to individuals the one thing more than anything else that's required for scientific, intellectual thought. What is that one thing that is the absolute prerequisite to do intellectual labor and discovery? Leisure. There's the one thing that is probably more necessary than anything else. Aristotle tells us in the first book of the Metaphysics how the sciences started. They started in Egypt. Why did they start in Egypt? Because in Egypt the land was rich enough that there was enough food, that they were able to create a separate class, the priestly class, that was leisured, that didn't have to work for its livelihood every day, could be supported by the society, and as a result, they turned to intellectual activity, inventing mathematics, geometry, and all the other sciences. Okay. Now, here's what I love to tell my students, because either they don't believe me or they just laugh at me, but I'm used to my students laughing at me, that's fine, that the very word school comes from the Greek skole, which means leisure. Because schoolwork is leisured activity. You might not always think it. My students don't always think it. But it is. And if you put it back in the context of the Middle Ages or the early modern period, which would you rather be? Would you rather sit in this lecture and listen to me drone on? Or would you be rather out in the sun raking your plot of beans and cleaning up after the cows? Your choice. All right. The other thing that the church was able to do besides supporting the universities was to supply benefices. These were ecclesiastical emoluments that someone would get the rent from a particular bit of land by taking holy orders. So, for example, monastic centers, universities themselves, Trinity College, to use a local example, still acquires a great deal of funding from rents of land. Here's something that I learned quite recently. I did not know. Apparently, even Galileo had a benefice which he acquired just before actually his problems with heliocentrism. He was actually tonsured on his knees by a priest to take holy orders, the first level of holy orders, and get a benefice. So even Galileo was supported this way. Another example would be the orders, that is, the monastic orders. The one I want to talk about, not so much in this lecture, but in the next, is the order of priests, the company of priests known as the Jesuits. The Jesuits, founded in 1540, opened vast numbers of schools. Within the first 100 years, they had opened nearly 1,000 schools, not only in Europe, but already in the New World, in North and South America, and in Asia, and even in North Africa, amazingly enough. One of the remarkable statistics that's thrown around a bit is that by the year 1700, if we count up the chairs of mathematics in universities in Europe, by 1700, more than half of them are occupied by Jesuits. More than half. The Jesuits themselves turned particularly to things like optics, physics, magnetism, falling bodies, astronomy. We have to ask why. Why would this order of priests be so deeply connected with scientific inquiry? There must have been something about their formation, their interests, their goals that made the study of the sciences extremely important to them. All right. So, let me move on. We'll talk a little bit more about the Jesuits later. Finally, I want to get to the way I'm really going to answer the question. Those were the preambles. The way I really want to answer the question is, can we identify specifically religious outlooks that have motivated towards scientific discovery and development, like what I was just saying about the Jesuits? Are there theological principles or perspectives that lie at the foundation of work in the sciences? And might these kind of principles even have informed the character and the kinds of formulations that we give to science? If we can show that this is the case, then I think this kind of what I'll call an organic and direct connection between religious and theological belief and motivation in the sciences provides a more compelling case than the avenues I mentioned before. Well, the answer to these questions, yes, right? There's enough anxiety in the world. I won't keep you hanging. The answer is yes, there is. Indeed, there are a variety of ways in which religious outlooks and motivations inform scientific study. Now, if we restrict ourselves even just to Christianity, which I'm going to do in this lecture, even within Christianity by itself, there are enough different perspectives and avenues that there are multiple ways in which religious belief undergirds or motivates towards scientific inquiry. I'm going to give you a few examples now, a little bit of a smorgasbord of people here. Let me start with the Middle Ages, with a chap by the name of Hugh of St. Victor. Now, Hugh of St. Victor lived in the early 12th century. He was a teacher at a monastic school of St. Victor, an abbey, just outside of Paris. And remember, it's out of these abbey schools that the universities eventually develop. This is just before the flowering of the universities. We don't know his exact dates. He died probably around 1140. I'm not absolutely sure. He wrote a text for his students, and for most of all for teachers, called the Didascalicon. And what it is, it's a list of what you should know. If you're going to be an educated person, here's what you should know. In other words, here's what you should teach your students. It's sort of an outline of a curriculum. But besides telling you what you're supposed to know and what you're supposed to teach, he also is very interested in why. in why. And this is one of the most remarkable comments about why you should be a learned person, why it's better to be learned than to be ignorant. Okay, so let me see. Right, he starts out with the principle of the Trinity, the Godhead of Father, Son, and Holy Spirit. One God, three aspects. From Genesis 1, we know that God has created man in his image, and therefore man himself has a threefold nature: soul, body, and mind. Now, this is wonderful. This is the creation of life in the Garden of Eden, where God and man spoke freely to one another, had perfect knowledge of each other. But as we all know, that situation did not last. There comes fall, sin, that divides man from God. Probably lower. I didn't mean to make any kind of theological implication by putting God and man on the same level. That was purely an artifact of PowerPoint. But now we find man in a fallen state. We can no longer speak and hear God back. And so we have been separated. A veil has been put between us. Our bodies have become weakened. What's the first thing that happens? Women, I will increase your pains in childbirth. You will work by the sweat of your brow. So our body now is subject to disease and to illness and to weakness and to the elements. So the body too is fallen. The mind now is clouded. In Eden, Adam was able to understand things immediately because he had the sense of intellection that was able to tell him about the world. But now, we can't do that anymore. We look at something and we see only its exterior. We don't understand anymore. We've lost that ability through sin. All right, well, what's the answer? The three kinds of learning is what Hugh of St. Victor answers. That on the one hand, we have theology that works upon our soul to bring us back into contact with God. It elevates our soul by teaching us about divinity. That's theology. Okay? That part might not surprise you. But what does Hugh then go on to do? He then goes on to list the 7 liberal arts: the trivium, the quadrivium, grammar, logic, rhetoric, geometry, arithmetic, music, and astronomy. Through these 7 liberal arts, our mind is re-elevated. We learn about the world, we learn about how to understand the world, and we regain, in a sense, some of that knowledge. It elevates us further towards the divine, back to that lost state. And then Hugh does something that's even more remarkable. He's one of the few people in the Middle Ages that does this. In addition to the 7 liberal arts, he likes symmetry, you could tell, right? Very Platonic. Great flowering of late Platonism in the Middle Ages. He adds 7 mechanical arts, which all function on the body. So we get sick. We need medicine. Medicine is a mechanical art. It works on the body. We're subject to cold. Fabric making makes us clothes. We get hungry. Cooking gives us food. We, unlike other animals, don't have claws to defend ourselves, so we now have armament making as another mechanical art to protect us. He even includes trade and commerce. Why? Now this is an odd thing. Why would he include trade and commerce? Because he says it makes us voyage beyond our own lands into the lands of other people we don't know and come to learn about them. And once we develop, this sounds very modern in a very strange sort of way. Once we come to know these people and we depend on trade with them, we must then always be at peace with them. Because if we're not at peace with them, then we disrupt our commerce. And we've come to know them. So trade and commerce gives us peace. And finally, one of the other mechanical arts is theatrics. that it gives necessary rest and ideas for the body, that we're not always working, so we get a little bit of rest. We achieve, again, some of that rest of the garden through theater. So what is he really saying? What he's really saying is that intellectual and technological knowledge is, in a way, salvific. Now, through the incarnation, death, and resurrection of Christ, heaven is joined to earth again, and so there is no longer this barrier between God and man, between heaven and earth. They are one now through Christ's actions. Yet we still live in a fallen state. So, whereas Christ can open the gates of heaven for us, it is through knowledge, intellectual, technological knowledge, that we can advance our state in this life, coming to know God, coming to approach God more and more all the time. Now, this to me is a very powerful argument for why we should study things like astronomy and mathematics and music and technology. They are, for him, the ladder by which man can ascend. All right, let me go on to someone else now. Oh, I forgot my PowerPoint. There, you can see how theology, the liberal arts, and the technical arts help each for one of the three parts of man. Right. There he is. This is the next person I'm going to talk about. I'm going to jump forward out of the Middle Ages to the early modern period and look at the astronomer Johannes Kepler. Now, Kepler, very well-known character. Anyone who's taken an introductory physics course learns his so-called 3 laws of planetary motion, discovered that the planets move in elliptical orbits with the sun at one focus of the ellipse. He discovers relationships between the planet's orbit, the distance from the sun, and the time it takes to revolve around the sun. He also talks about what he calls the equal area law, that says that in any given period of time, the area swept out by a planet in its orbit is always the same. These are actually only 3 laws, relationships in astronomy of literally dozens, maybe even hundreds, that Kepler worked on. Now, Kepler was absolutely firm in his conviction that the study of the natural world, in other words, these endless calculations that he did on orbital mechanics and stellar distances, this study of the world was inherently a theological exercise, inherently so. The study of astronomy was, in a way, a study of God. Now, what idea, what concept of the world undergirds this position? Well, this notion is perhaps the most widespread idea of all in the intersection of science and religion in Christianity, namely the doctrine of the 2 books. That God reveals himself to mankind in 2 qualitatively different ways. One, by inspiring the biblical authors, not dictating to them, but inspiring them to write the books of the Bible. But God also reveals himself in a different way by creating the world. That the world is somehow a reflection of God's own essence, his own goodness, his own being. Right? It's just like if we have somebody we know that we love, that we want to know more about. We want to know everything they do. We want to know about the kinds of letters they write. We want to know about the kind of books they write. We want to know about the kind of music they listen to. We want to know everything about them. If we have that same kind of love for God, then we want to know everything about what he does. Well, what does he do? He created all of this. And therefore, in studying it, we come to know more about divinity. The concept itself dates back to the early patristic period. It's perhaps most closely linked with this man, much later. Of course, I have no idea what St. Augustine looked like, but St. Augustine of Hippo, the African doctor of the 4th and 5th century. I think I can say without any fear of contradiction, the most important intellectual of the first 1,000 years of the Christian era. And if you want to think of the most important intellectuals of human history, he's probably in the top 10. What he's known for, of course, I can't get into this now, was a harmonization of Christian and Hebrew revelation with Greek philosophy. He set down all kinds of rules, one of which I'm going to talk about in a moment. Think about what 2 books actually means. Really think about books. When we read a book, do we just look at the cover? No, we have to open it up and turn through the pages. When we read the Bible, can we just read it for its literal sense? Well, Augustine would say, absolutely not. You'll end up thinking silly, naive things like God created the world in 6 24-hour periods. My favorite argument of his is, if the sun is only created on the 4th day, how did you know the first 3 days had passed? You'll think that God weeps and laughs and is angry. So the Bible, the book of Scripture, requires a developed hermeneutic of how to interpret it, a critical exegesis. And Augustine wrote lots and lots of text on how exactly to do that. But the book of nature is the same way. We cannot just look at the world and make simple observations of it and come to understand it, because all we get is something superficial. There has to be a hermeneutic for understanding the book of nature. And what is that? That's what we call scientific methodology. To look behind the appearances of things. And Augustine does this too. He's got a whole section about how the classic example from Greek philosophy of the bent twig, of a twig that's stuck half stuck in a puddle of water and it looks like it's broken because of refraction. He says, well, just look at it, we'd say it's broken, but it's off. We pull it out, it's obviously not. We put it back in, it looks like it. So our senses deceive us. Our senses don't give us immediate knowledge of the world. So we have to be really careful. Now, Kepler, let's get back to Kepler. Kepler, like most of his contemporaries, was fully aware of this idea of the doctrine of the 2 books. God gives us 2 books. If we want to know about God, we have to look at both of them. So, he wrote at one point to his teacher in astronomy, Michael Mestlin, quote, I wanted to be a theologian. For a long time I was troubled, but now I see how God is praised through my work in astronomy. In short, Kepler's discovery of the laws of nature, of mathematical relationships in celestial mechanics, the shape of planetary orbits, of optics, and all the other things that he did, was a discovery of the mind of God crystallized into the operation of his creation. For him, he was not finding mere formulas about celestial mechanics that would end up in 21st century physics texts. That's not what he was doing. What he was doing was tracing out in the world the thoughts of God himself. He was tracing the lines in the blueprint of creation through the relationships that he discovered mathematically through observations and through calculations. So his quest, this thirst to know the divine mind, is what drove Kepler onward through enormous personal anguish. He had a very miserable life. His mother was constantly being arrested for witchcraft. I think she was probably a bit crazy. His wife and children die of the pox. He's never paid for anything that he does. He has to leave one place or another because of the religious wars that are going on at the time. But what drove him on was this desire to know the divine mind. Now, Kepler is one of these people who saw his scientific and theological interests as a single, seamless garment. Indeed, since the 2 books, the book of Scripture, the book of nature, have the same author, who, unlike a lot of us as authors, is supremely self-consistent, the 2 books can't have any contradiction between them. So they have to be consistent. They have to be deeply connected with one another. And so what we do is we find Kepler easily moving theological ideas into the scientific realm and scientific ideas into the theological realm. This is not unusual. This is very typical for the period. Kepler's not the only person that does it. I'll give you an example. Kepler is one of the few people of his period who was fully convinced that Copernicus was right, that the sun was at the center of our system and the earth was in motion around it, not that the earth was at the center and the sun moving around it. Why? Well, there are a number of reasons. But one of the first arguments he gives for it is that in this way, the universe is again the image of the Trinity. When he starts in his epitome of Copernican astronomy to try and convince his readers that Copernicus was right, he says, well, look, the sun at the center is like God the Father, who is the source of all things, whose light radiates out and fills the universe. The sphere of the fixed stars is God the Son, who sees all and absorbs the light of God the Father, reflecting it back to the center. And look, Kepler wrote one of the most important books on optics. He knew that if you had a spherical mirror and you were inside of it, in the middle, you looked out anywhere, what would you see? Yourself. Because every ray of light is reflected back from the sphere to the center. So God's love, God's light radiates out to God the Son and is reflected back in perfect unity to the central point. The space in between, says Kepler, is the physical image of the Holy Spirit, the relationship between Father and Son. So, you can see that a theological principle deeply held by Kepler influences his choice of a scientific system. Likewise, he did work on dimensionality and dimensions in the world, stellar distances, all kinds of things. His work on dimensionality and optics and space convinced him, now he was a Lutheran, it convinced him that Luther's doctrine of the Eucharist was wrong, that consubstantiation could not be correct, and that, in fact, the Catholic doctrine of transubstantiation or the Calvinist doctrine of consubstantiation, one of those had to be correct, but Luther could not be right on physical, scientific grounds. In fact, he was excommunicated from the Lutheran Church as a result of this. Okay. Now, the image of the two books I mentioned to you, we find it all over the place. And Galileo himself refers to it. He talks about the great book that is open constantly before our eyes. And for him, it is written in the language of mathematics, of spheres and circles and lines and points. Now, someone else, the last person I'm going to tell you about today, also talked about the great book of nature, but very different from the way Galileo saw it. For Galileo, it was a book of mathematics. For Kepler, it was probably a book of mathematics too. But for this one, it was a well-written romance. This was Robert Boyle. See, I can get the picture of it. There he is. Robert Boyle, say a little bit about him. Born into one of the wealthiest families in Britain, the 14th child, 7th son of the great Earl of Cork. Boyle is, again, a person that you will run across. You may have run across him in your chemistry classes as the originator of what's come to be called, in later times, Boyle's Law, that the pressure and volume of a gas are inversely proportional to one another. He worked on pneumatics, worked on an air pump. He is also sometimes called, with some validity, but not a lot of it, the father of chemistry, because of his very important role in founding chemistry as a respectable discipline. As a chemist, I sort of hate the idea that at one point chemistry was not a respectable discipline. It's true, however, but Boyle did a lot to make it respectable. let me say a little bit about, well, let me say a little bit more about him. He was a deeply religious man. When the Bishop Gilbert Burnet, his confessor, Bishop Salisbury, gave his funeral oration, he referred to Boyle as being essentially a lay bishop. Very deeply religious man. He was Anglican in profession, although very ecumenical in his thought. Very, very ecumenical. I'll talk a little bit more about Boyle next time, but let me say how he started out. We used to think that Boyle, from his youth, was interested in the sciences. We now know that this is no longer the case after studying his papers that are now resident of the Royal Society of London. He started out writing moral and devotional treatises. His moral treatises were pretty dry, they didn't get very far, but he also wrote devotional treatises using the style of, very popular at that time, French romances. Writing romantic stories of the martyrdoms of saints, for example, or one work, most important early work, called Seraphic Love, which he wrote in 1648, wasn't published until 1659. It was actually the first book that was published under his name. Seraphic Love takes the form of several letters, and the first several are lost. We only have the last letters, which is what he published. He may not have written the first letter, but the idea is he writes to a friend of his named Lindamore, who seems to be rather interested in chasing the young ladies, and is very sad about having bad relationships with them and that sort of thing. And so he writes, Boyle writes Seraphic Love to him saying, well, look, there are all kinds of loves in the world. What you want to follow is the seraphic love of God. This is much better. It'll make you much happier in the end. And Boyle himself took the advice. Boyle never married. We never know of any kinds of, almost no, relationships of his. He devoted himself. He devoted himself to a study of science, experimentalism. He lived with his sister on the Pall Mall for the last 30 years of his life. I've often wondered what his sister made of this, with various explosions and bad smells and people carrying around buckets of blood and manure and that sort of thing through her fine house on the Pall Mall. But unfortunately, she doesn't tell us. When Boyle first gets interested in science, he writes a book which is called, appropriately enough, The Book of Nature. And in this, he talks about how, wow, I've just discovered this thing called natural philosophy. And I have a laboratory now, and I do all these things, and I find out all kinds of neat stuff. And what's so great about it? It directs my mind towards God. It instantiates theological and religious principles. He writes a very excited letter to his sister when he first discovers chemistry, and he's doing distillations and crystallizations, all kinds of things. And he writes to her and he says, very soon I will entertain you with a short treatise I am writing on the theological applications of chemistry. Now, unfortunately, he never wrote that, or if he wrote it, it's lost now. But this is his kind of idea. Like Kepler, for Boyle in particular, the study of the natural world was a kind of devotion. It was a devotional activity. In fact, what he says is that I like to do natural philosophy, especially on Sundays, because it's a kind of prayer. He also says that he says a lot about the role of the scientist, or the natural philosopher, what we've called scientist. He calls the natural philosopher the priest of nature. What does he mean by that? What he means is that the priest is supposed to gather up the prayers of the people and direct them to God. So gathers up the prayers of the congregation and offers them as a sacrifice, as an offering to God. The priest of nature, according to Boyle, is to gather together the mute prayers of the natural world, of everything that's created in the world that praises its creator silently. And by coming to understand that praise, gather all that together and offer it up to God. So the scientist is the priest of nature. At the end of his life, Boyle wrote a book called The Christian Virtuoso. It was published in 1690. He actually died before finishing it, so only the first part of it was published. Here, the word virtuoso means the same thing as a natural philosopher. It's someone who has a virtuosity for studying, particularly the natural world or unusual things. It was written as an explanation of Boyle's own life, as well as an invitation to others to join in his project. It dismisses, first of all, the idea, which in fact, if he's dismissing this idea, it must have been in some kind of embryonic state somewhere. He's obviously talking to somebody when he's answering the notion that scientific study might be deleterious to religious life and belief. No, Boyle says, I will have none of this. This constantly strengthens our devotion and our belief. Because once we understand the book of nature, we understand the book of scripture better, we come to understand God. Scientific understanding, scientific study, brings us to a greater devotion. So, what we have here is Boyle at both ends of his life, with seraphic love, with Christian virtuoso, sort of making bookends to his life of religious and devotional interest. And all in between is his scientific work, although he continued to write theological works in between. But you see, this is something that happens over the course of history. You think of history as a river. It carries some things down to us and other things that get hung up on the rocks. And so what we have are little scraps of things. And it takes the historian to grab us by the hand and pull us upstream to see the things that have been left behind. And the parts that have been left behind for Boyle, for Newton, for Cambridge, I should mention Newton, are often their theological motivations. Right? The textbook writers sift out what's interesting from the early modern writers. So Kepler's 3 laws fall out. And his idea about heliocentrism being proved by the image of the Trinity gets left behind. Boyle gets put in the sieve, and Boyle's gas law, and his ideas about atomism, and his ideas about pneumatics come through. But the context that this was done essentially as a kind of devotional activity gets left behind. So we constantly have to remember, we have to remind ourselves, this is what historians do. This is our purpose, to remind people of the things we've forgotten. Keep reminding, keep reminding. All right, let me just sum up in a couple of minutes. So we can see now, I hope I've given you some examples where religious belief provided either a background or a motivation for the development of even some concrete modern scientific ideas. It could provide an impetus and a reason for study. It could transform scientific experimental work into a kind of devotion. Or, in Boyle's case, one thing I didn't mention is that he related his scientific work, he even brought Christian morality into his scientific work. How does one do that? By being absolutely sure that you're interpreting things right before you tell other people about them. By making sure that you don't do a halfway job, that you are what he calls morally certain about your results. Morally certain. So it can even keep us, scientifically speaking, on the straight and narrow, that we will in fact interpret our results correctly and do enough experiments to make sure we get the right answer so we don't lead other people astray. A man like Boyle or Kepler was not religious on Sunday morning and then scientific on Tuesday, Wednesday, Thursday, and Friday. We moderns, we like to divide things, keep science and religion at a safe distance from each other, but this is a modernism. For them, our question about could there possibly be religious motivations to scientific study would have sounded incredibly bizarre. What planet are you from that you would ask a question like this? Of course it is. Thank you.
Well, thank you very much, Larry. That's a terrific talk, so I'm sure it's prompted some questions. Yeah.
A very interesting talk, which I appreciate, but as a biologist, I'm feeling a little left out.
Oh,
of
sorry,
the
yeah.
discussion. Could you add anything in there, or perhaps that comes along
Sure.
later?
Okay. Well, first I'll say, how about, actually, there are a lot of good examples. Natural history sort of early modern version of biology. Natural history, my apologies for being so much a physical scientist, right? Natural history, absolutely, because we have many people who say there's an obligation to go out and catalog what's in the world, because we're listing how rich God's creative activity actually is. And a good amount of natural history, we tend to forget this, even like me living in the New World, we tend to forget this, that a lot of this information that really was critical to the development of biological sciences, so flora and fauna, that sort of thing, comes out of the newly discovered lands in the early modern period, from North and South America, from Asia, from the southern part of Africa. Who was doing that work primarily? Well, largely it was religious orders. Franciscans, Dominicans, Jesuits. And contrary to the kind of Hollywood-esque versions we get of this, we don't have the religious orders coming in with sword and fire and burning up the native knowledge. Instead, what we have, if we look at people like Sahagún, a Spanish Franciscan, a lot of other examples, they actually go and they learn the native languages. In Mexico is what I'm talking about, Nahuatl. And they learn the native language, they teach the native peoples Latin, and they work together on producing these texts of natural history. Quite remarkable, with the illustrations, 2 columns, Latin, Nahuatl, and all done by native scribes. And these manuscripts are still in Spain today, or in the Vatican. So certainly, yeah, I'm glad you brought up the question of biology, but that's certainly there too.
Thank you.
Great, thank you. Dennis?
Yeah, I thought your picture of the Trinitarian theology impacting on Kepler's thought was really interesting, and I wondered if you could give us some more examples of maybe where not just theology as a motivation for doing science, but actually had spilled over into influencing the content of some of these medieval natural philosophers, and maybe Boyle or other examples of that. It would be interesting.
Yes. Yeah, well, let's see. Another idea that Kepler has towards the end of his epitome of Copernican astronomy, or is it in the Harmonies of the World? I don't remember at the moment. Is he gives another argument for heliocentrism that, let me see if I can explain this. He says that God and man know things in 2 different ways. That God knows things by intellection, which takes no time whatsoever, the way man used to in the garden. Okay? So we just know something instantaneously, like a sudden vision. Whereas man has to use reason. Okay? And reason takes time. We go step by step from a problem to some kind of solution. And he says, well, this makes perfect sense. This reinforces heliocentrism. How on earth? All right, well, God, the Father, is represented by the Son that sits motionless at the center and sees everything at once. Whereas man is on the earth that is moving around in a circle, or an ellipse. Sorry, Kepler, an ellipse. How does this make this connection? Well, he says, well, we would never be able to know anything about the distances of the planets unless the Earth were actually moving so that we could observe parallax. And so it's like the action of human reason. So it's another kind of argument that he gives. Let's see if I can think about this. I can't think of any others at the moment. I don't know why, but there are quite a few. There's the
What about Boyle? Do you think that Boyle, because he had a very radical understanding of God's interaction with the world, there were no empathies or sympathies, and he hated nature as being a kind of intermediate thing. I mean, do you think that had a kind of impact upon his own understanding of the world like a big machine and corpuscles, and is that sort of connection there maybe? Or,
yeah, it certainly did. It reinforced the idea that there wasn't an intermediary that we were really finding out. We're not really finding about this so-called nature stuff, because there's only God and his creation. So it undergirds the notion that what we learn about the natural world really does say something about God, not about some intermediary step. As for his ideas about machinery, of course, there are certain ideas that Boyle has about the way God works as an artificer. Now, I'll talk about that more when I talk about natural theology in an hour or so. That the world is like a machine, that God puts, that God not only does man do things like God, but God does things like man in a sense, because we share a certain level of nature. Yeah.
Thank you. At the back, yes.
I'm coming back to Kepler.
Okay.
I'm just wondering a little bit, and maybe my understanding is mistaken, so please correct me where I got it wrong. But some of the things that I believe Kepler thought, because of his ideas of the perfection of God's creation and his moulding the observations to fit, his obsession with the Platonic solids and trying to actually led him into wrong pathways. Actually led him into wrong pathways and perhaps dead ends. Now, I wondered if you'd like to expand on that.
Certainly, I'd be glad to. Science is not just getting the right answer. It's a project of investigation. And for Kepler, his interest in the Platonic solids, actually the calculations, given the planetary distances that he had, worked out quite remarkably, in fact. So he had every reason to think that he was right. The motivation for him was, I don't think that he sort of fit observations to his preconceived notions, because Kepler, if anything, was a tireless calculator. And the whole Astronomia Nova, it's quite a large book that he publishes in 1609, 1604, is about calculating the orbit of Mars. And the first 9/10 of it is about all his calculations that didn't give the right answer. So finally at the end he says, oh, well, I've tried everything else, we'll try an ellipse. And it works, right? So he's not tricking himself at any point. Yeah.
Thank you. Yes. Yeah, then John.
I have two sort of critical comments, but I really mean them in a constructive manner.
Good.
So,
Fine.
first comment has to do with these ideas of Kepler, the theology that he used to sort of justify heliocentrism, etc. I think this is a bit dangerous because it gives ammunition to people who really want to keep religion and science separate, because they say, you see how naive or how even stupid these theological ideas can be, since of course we now know that the center is not at the center, the sun is not at the center of anything. The sun moves, the sun is just one ordinary or less than ordinary star, etc., etc., and you know, the sphere of stars no longer exists, and the Son of God reflecting the light, etc. So these projections, which we have seen in many cultures, including in the Islamic culture and before, of people taking philosophical ideas or theological beliefs of any kind, and saying, okay, this is how science, this is how my science should be developed, or this is what justifies my discoveries or inventions, which 9 times out of 10 turned out to be incorrect. So I don't quite subscribe to, you know, these projections of theology or philosophy into science, etc. So I think we should be careful about looking at the content of the discoveries and saying, you see how the religion or religious backgrounds helped them. It helps them maybe justify that idea, but in the long run it wasn't very constructive or productive. The second comment is sort of flows from this, and it is that modern science is really a revolution in method. It's not the content, it's not heliocentrism, because we now know that, as I said, the sun is not the center of anything, etc. It is, yesterday we kept talking, I don't know at what point you came or if you were here the whole day, but in the morning and especially in the evening, we talked about methodological naturalism. I think that we need to emphasize the serious fundamental difference between science in general as it used to be understood before, and I talked yesterday afternoon about Islam and science, and of course before that there was Greek science, Egyptian, Pharaonic science, Indian science, Babylonian science, etc. It was all science. By the way, the doctrine of the two books exists verbatim in the Quran, exists in Islam, etc. But what really identifies modern science and makes it such a new project and forces all of us to look at the relationship with religion, Christianity, Islam, or whatever, is the fact that it forces a new method. It's methodological naturalism, it is empirical and experimental method, it is falsification, it is peer reviews, etc. And those things barely existed before. And so what I would have liked to hear, because the title of your talk was the role of religion in the emergence of modern science. What you have shown is that religion, Christianity, etc. encouraged science, not necessarily modern science, not the new methods, but they encouraged science. This is great, this is good, but it existed also before and it continues to today. And people will say, of course, people can be motivated by all kinds of beliefs or all kinds of philosophical viewpoints. But the fact that modern science emerged in Europe needs to be explored, and where did that come from? How did, as you say, or as some people say, Dennis in his book, that modern science was fueled or was somehow given birth to from some of the religious principles. And this is what we need to show, but we need to show sort of more directly, not through examples of people like this. So that's my comment, and I hope you can...
All right, well, I have two answers. I'll take them in reverse order. First of all, this is where modern science starts. It's not in the 19th century. The foundations of our methodology come from the late Middle Ages, the 17th century, and the 18th century. Peer review, replication, empiricism, experimentalism, it's all right here with Boyle and Kepler. So there's a problem, there's a historical problem when people say that science is a production of the early 20th century, the late 19th century, the early 19th century. It's just not true. Because these are the people on whose shoulders it rests. They are the ones who create things like scientific journals, scientific societies, the principles of doing experiment, like the Accademia del Cimento in Italy in the middle of the 17th century. They are working out the methodology. Now, it is true, you are right, that many modern scientists want to cut themselves off from this, but that's a fool's errand. It is impossible. It is impossible. It cannot be done. Now, your first comment was one about whether or not this is dangerous. Well, first of all, let me say that...
Sorry, but where's the connection to the religious principles in that? I don't dispute that modern science started much earlier, but I say, let us show that the theology led to the revolution in methodology that produced modern science, not just science.
The theological principles behind those things you just said, like experimental method.
Right. Well, I suppose if I had given another talk, I could do that as well. Certainly, the idea of experiment, that we go and we look at the world, is undergirded by ideas about intelligibility of the world, human ability to understand, the kind of concepts that are inherent in the human mind, that are implanted there by God. That's a huge topic, goodness. I don't know that I could answer that straight away.
But that's the topic. I mean, when we say the role of religion in the emergence of modern science, this is what we mean by emergence of modern science, meaning...
That's not what I meant when I wrote this lecture.
But modern science, that's what we mean by modern science.
It's not what we mean, that's what you mean.
No, sorry, what's the difference between... what do we call modern science then? What is modern science as opposed to just science?
Well, you see, science is not a static thing. I mean, is yesterday's science modern science? Is tomorrow's science modern science? Here is a modern science with Boyle. It is modern for Boyle's standards. It is similar to ours in many ways. It is different in many ways. Just as if we say modern science emerges in, let's just pick a date, 1925. Right? All right, it's modern then. Well, it's out. A lot of scientists would say, well, no, it's not out. It's outdated now. And the science that we study in the 22nd century will show what we're doing is outdated, even methodologically. So I think we make a mistake if we tie ourselves to making strategic kinds of decisions about what we will and will not say. As historians, what we have to do is talk about the way things are, the way things were, and the connections that tie us to the past in an unbreakable link. And so I'm simply just less worried about strategizing than I am about getting the facts right historically.
Okay, thank you. John White had a question.
I had some of my question was the same. In particular, the rise of the empirical method, because I think people see empiricism, and certainly Boyle and Kepler, the desire to create detailed observations and to see what was there rather than what ought to be there. How do you see that tying up again with their theological?
Yes, that's very clear with Boyle, with this idea of moral certainty, that we can't just have some notion, a preconceived notion about what's going on in the world, because essentially we'd be misrepresenting God and his activity. And so there is a moral imperative to be empirical and to derive conclusions very, very carefully. And in fact, Boyle's quite explicit about this, that he uses some of the same questions for the examination of conscience, religiously, before speaking to your confessor, for example. He translates those almost directly into the kind of questions you ask about experiments and our understanding of experiments. So that's one case where empiricism and religious belief are very close.
Does the contingency of the world as a theological doctrine come into this?
Yeah, it has to, in one way or another. I mean, on the very largest scale of all, for any of these people to have done any work, we have to assume that God has some kind of covenant with the world. The world will continue to function in rational, regular kinds of ways.
But I mean, God could have made it differently.
God could have made it differently.
And that might motivate the experimental method to find out how he did it.
How he actually did it, yes,
Yeah,
right. Because as I say, we're tracing out the lines of the blueprint that God actually used, not what he might have used, but what's actually there in the world. We can find out.
There's a question here first, and then.
I read an article in Discover magazine, I think it was back in December, and it spoke about the centered on the issue of the multiverse and a scientist's pursuit of that. And the article, in interviewing him, made it clear that the reason for his pursuit was philosophical. He didn't like the theological implications of the Big Bang. And it seems to me that based on what we heard yesterday as well, that a personal philosophy, personal perspective, personal worldview has always played a role in a scientist's choosing whether to venture this way or that way. So I personally see a great relevance here. And I see a continuity even with modern science. I mean, would that be accurate?
Yes. The biggest lie that we are told about science is that it is impersonal. It is not. It is emphatically not impersonal. Because simply all the experiences that you have from the time of your birth till the time you're sitting right here influence the way you see and influence the way you process information. And all of us do that differently. And when we're in the laboratory, when we're outside, when we're driving, no matter what we're doing, we're processing according to a set of mental operators, a mental landscape that has been slowly built up and is unique to us. We can't get away from that. So, yes, absolutely.
But maybe the response to that would be that our theories or whatever might have a personal motivation, but they'll get sifted by what's actually out there.
There is some of that, of course.
Might or might not be.
That's right. There is obviously going to be, through a kind of communalism, which is the kind of thing that scientific societies of the 17th century are trying to work on, of how do we come to a consensus, how do we agree on what we're actually seeing. Well, of course, that works to a considerable extent, but often the group has some communal ideas too. In this case, with the Royal Society, they would all have been Christians, so there's certainly a certain theological uniformity that will come through, that will not be sifted out, if you will. common denominator.
Right, yes, there are two questions about. Okay, yes, you first, yeah.
To what extent did Kepler's and Boyle's love of discovering the work of God and the form of worship and what they did drive the excellence of their science?
To a considerable extent, because in fact what they are doing, and they're very explicit, I'm not imposing this on them, they're very explicit in several places in their writings, that what they are doing is they are offering their work to God. And to do that, the work has to be perfect. It can't be slipshod. So they're very clear about that point, that as an offering, quite perfect.
Yeah.
Correct me if I'm wrong, but I understand you interpreting the theological background as being a reasonably benign understanding of the book of nature. But at that time there was also some fairly negative sort of theological interpretation of nature, and I was wondering how that affects the emergence of the new science.
There are some radical Protestant views of the 16th century that talk about the world as sinful, but those are actually quite a small minority. There was a paper written recently in ISIS, actually, the Journal of History of Science Society, that talks about different natural histories and how the different ways natural histories present the world, or the collection of flora and fauna in the world. How they show that is based upon particular confessional claims of their authors. This is in Germany, between different kinds of Calvinists and Lutherans. I don't honestly know a great deal about that, but in most cases, just to answer your question more simply, those people who are going to be studying the natural world are going to be interested in it. They're going to have some kind of, they might feel that it has fallen somehow, it is imperfect, but they're going to have generally a positive outlook on it. I don't know of many examples of a negative notion of the world and the things in it that actually impinges upon scientific inquiry. I can't think of an example of that.
And to go back to the question by Dr. Gassoon here, I think wouldn't it be helpful to make a distinction? If you're talking about the origins, the way in which Christianity is influential or is part of the origins of modern science, wouldn't it be right to say that the way in which it functions in your argument is to say that that the founders of modern science, the people you're talking about here, did their work in a theological context. They saw their work, they saw science itself, natural science itself, as in some sense cooperating with the work of theology. It is in fact it's reading God's book, it is glorifying God and so on. So it provides a supportive atmosphere, a supportive context for scientific work. And it encourages systematic and prayerful work about nature. That's certainly true. But on the other hand, I think the point that you were making, if I'm not mistaken, is did it in some sense influence what is specifically modern about the science that comes out of this, specifically modern in the sense of a distinctive new method and so on? And I think the answer there is probably no. I mean, if you take the person who contributed most, for example, to the modernity of the new science, who I think would be Galileo, the two new sciences, if you look at the different elements in the two new sciences that are distinctively modern, the various ways, the emphasis on, for example, mathematics on experiment and so on, I think you can trace the origins of those complicated origins of those in a different way. I'm not sure that what constitutes the science of the 17th century as distinctively modern would itself, so to speak, be traceable to the Christian context. So it seems to me there's a double answer here involved. Yes, Christianity is fundamentally part of the formation principles of modern science in the sense of providing a very supportive context for it. But I rather wonder if it is what, so to speak, makes modern science modern as against what went before.
I agree with you entirely. What I was taking as my theme
Yeah.
for this lecture was the first section.
Yes, I thought so.
Not
So
the
I
second.
think that enhance. I think, am I right in saying that you have the other in mind?
You bridged the
Yes.
two views perfectly, yes.
I guess my problem is perhaps I'm not philosophical enough to understand exactly what modern means in
Yes.
that sense.
Well,
I
that's
don't know what that is.
That's very complicated.
Yes, it is.
Everybody would debate that. But I mean, there are preliminary answers at least to that. I mean, there are distinctive, if you look at the way in which Galileo goes about his experimental work, the idealization, for example, the use of experiments that are not part of the natural world anymore. They're a contrived artificial construct, so that the Aristotelians can say to him, look, that's not the world anymore, that's a construct. This inclined plane of yours, that's not the way things work. This is, you're looking for an artificial world here. Now, that kind of move away from the natural world of Aristotle to the artificial world of the experimental method, that doesn't seem to me to be a distinctive Christian contribution.
No, I can't
So,
imagine it
I mean,
being
so I think there's a double thing going on there.
No, concur.
Yes.
Can I pose the question in the context of comparisons with China, let's say, and what Nidhal was saying yesterday about the Arabic world? So what was it about the distinctively Christian context of Europe and the sort of the flourishing of science, as opposed to, why didn't that happen in China and in Arabia in the same way?
Well, that's one of the $64,000 questions of the history of science, isn't it? I have been asked this question before, and I used to think about it more than I do now. The reason I think about it now is that, the reason I think about it less now, is that I'm not sure it's a particularly well phrased question or one that we can actually answer, simply because we are here in the present right now, and so we naturally ask about ourselves, right? But modern science could have taken a different route, in which case, had it done so in one of these multiverses, right, we would be sitting here asking, why did it happen the way it did? So if you see what I mean, I'm uncomfortable with over definitions of what modern science actually is. We only find out what it is by looking at it, and we only find out its sort of empirical method. We look at what people do, and yeah, it could have come out differently, but I'm not making myself very clear here. But I just don't know that that's really a question that we can answer. It's also historically contingent on how we got to where we are now. Had we gotten to a different place, we'd ask the same question and it would have a different answer, if you understand what I mean by that.
Yeah, so there's no particular theological distinctives that you would point to?
Well,
with China?
I admit my own ignorance about what's going on in China. I'm sorry, I have never made a study of that, so maybe we can have someone else tell us about it. I don't know it.
Yeah, well, I know there's several other questions, but perhaps we ought to have a Chinese comment on that.
I would love to hear an answer.
That question is we mostly discussed about Newton's question, because why China and was no emergence of modern science, and actually there are a lot of disputation about this problem. Actually, people maybe nowadays think about we better think about why modern science appeared in the Greek tradition or in Europe, because modern science is not appeared in Islam or India or China. If we want to seek out the reason why those areas has no appeal of science, that will be unanswerable. But we might seek why the science, modern science, has emerged in Europe, and one of the possibilities that the church, the Christian church, is unique might be some relationship with modern science. I think that's a big, because there's a, the relationship between science and religion. For the emergence of modern science, we might think it's very important because Christian has some unique importance, in this area, and for the Islam and Buddhism, we might not find some doctrines or encouraged to seek out the natures. There's some possibilities. I think that's what you are talking about, the emergence of modern science to be encouraged by church.
Well, yes, there are certainly two very simple things. They're so broad, it's hard to put your finger on them. But certainly one thing that has been said is the notion of monotheism, which gives you the concept of a uniform kind of creation where you don't have a pantheon of arguing gods undoing each other's work. So it gives you a sense that there's some kind of stability to the natural world that gives you something to study. The other argument, which has been made perhaps most prominently by Edward Grant, is that the emergence of the university, a church-sponsored institution, is significant to create a continuous tradition of scholarship that goes on from one generation to the next. Rather than just simply individuals who are adding things piecemeal, you have instead an institution in which scientific work, intellectual work of various sorts can be done that outlasts the individual. So those are two very broad ways in which we can talk about this, about the emergence of modern sciences in the West.
Thank you. Now, Jennifer had a question, and I think Dennis, and we'll probably have to end it there.
Okay, I just wondered if you could comment a little bit more on Dr. Gusum's first question, which was, if I can rephrase it, doesn't this discussion kind of fuel actually the support for the conflict theory between religion and science, in the sense that Kepler, for example, some of his religious interpretations of science would have led to the wrong answer, as Nidal said, that, for example, a sun-centered universe that fits in with the idea that God is the center of the universe, and now we know that the sun is not the center of the universe. So if you use your theology to guide your scientific interpretations, you can come to the wrong answer. So it's, you could say that that's dangerous. So therefore, you should keep your religious views separate from science and not be driven or motivated by them in any way, or it might taint your interpretations or even your practice of science. So do you have any comments on that?
I have two. Now let's see, they both just flew out of my head. The first is that we're always going to use something to help us interpret our science.
So everyone has a worldview, basically.
That's right. And it might be theological, it might be philosophical, it might be political, it might be economic. And there is no such thing as pure science. N'existe pas. I mean, it does not exist. Everything that we do in interpretation has to do with everything we do in science has to be interpreted. There's some kind of hermeneutic, right? So if we take the argument that religion and science should be kept completely apart from one another, well then we have to keep everything apart from science, and we're left with nothing whatsoever. What we might get is, no, we couldn't even. That was tried. It's called the Vienna Circle in logical positivism. It didn't work. It was absurd to try and say that you could have observational terms that have no kind of interpretational element to them. Okay? So I think you're probably right that someone could come and say, oh, well, Kepler got things wrong because of his theology. Well, yeah, science isn't necessarily about getting things right.
But I'd say most of my scientific colleagues would probably at least self-delude themselves that they can do science objective, that they can, that if you divorce the philosophy and theology from things, you can come to an objective answer that's not tainted heavily by a certain worldview or philosophy.
delusional.
Okay, Dennis, and I think we'll have to.
Well, it's just a reflection, really, since we're here in Cambridge, the home of Herbert Butterfield, and I mean, I think the conversation we've had sort of reflects very much, the view of the modern scientist, the view of the historian, and of course, modern science so often wants to track, the pathway leading to modernity,
And
ask the
pathway,
historian, how that happened, what was this pilgrimage, that led to our present place of obviously perfection, a scientist where things are pretty objective, we have it wrapped up. So, whereas a historian is always looking at the contingent events, as you have been, and refusing to admit modernity. And so I think it's a classic example, actually, of the normal discussion that goes on between, scientists and the humanities, and the sort of meeting in the middle there somewhere. But I just wanted to make, since we're here with Butterfield's home, I just thought we ought to flag up his Whiggish view of history in that way.
Yeah, that's
as
very
part of this
elegantly
discussion
put.
going on here, I think.